Okay, we'll take a look. So we've been looking at Matplotlib, and we covered all of this stuff. There's an important thing, and I don't have a notebook directly here. Okay, but what you should do is go search Google, type in pandas visualization. Okay, number one hit should be the user manual. My phone thinks that I'm talking to her. Okay, okay, so you're gonna click pandas visualization, and this will be the document. Okay. We can just walk through this and talk through this, okay? But you should try all of these things out yourself, okay? And get a sense of just using plot from pandas directly, okay? So a lot of pandas data frames, you can just do you can take the data frame and then call plot on the data frame directly, and it will make plots, and it's super great. And I think this was briefly covered in one of your data camp assignments, right? Yes, okay. Thank you. All right, so anyway, in addition to importing pandas, you got to make sure you import matplotlib pyplot as PLT. And then and here we've done some things. So here we're just looking at some random numbers. We're just creating a pandas series. Gonna zoom in here, okay? So we created a pandas series, just 1,000 random normal numbers, okay? Starting, and then we just provided an index with a date range, okay? And so, you know, can you visualize what this series looks like? If I were to call this in, I just started doing this, okay. So, you know, try some of these out, okay? Get rid of this stuff here. And you can just see what the time series looks like. So it starts January 1, and then we just have some random numbers. And then what do we do, okay? We're going to change the series to be the cumulative sum, right? So every day is just going to be the sum of what happened the day before. Okay, and then we can print that out. And so we can see if we took 1.2 and subtracted 1.9, we would get that. And if we subtracted 1.34, we would get that. And then you can just call plot on the series, ts.plot. And because it has an index, in all of these values, it prints it, and then the index, which is date information, it recognizes it as date information. It gets printed as you get dates along here. Okay, so a lot of times, if you have the index properly specified and you ask for the plot, you get a nice output here. Here, we've basically got 4 of these things, okay? And then the columns are A, B, C, D. So the plot okay. So it's interesting. You can just call list on a string. This is not something I've taught you guys, but Python does some cool stuff. You can call list on a string ABCD, and it automatically turns it into column names here, or not column names, but a list A, list with element B, and then C and D. Okay, so now I've got basically my indices are the dates, my column titles are A, B, C, and D, and then we're going to call cumulative sum on this again, and then we can just say make a plot and then draw the plot. So we'll call cumulative sum and then we'll say make a new figure, and it draws it. Okay, and because the index is provided and the column names are provided, it automatically throws in a legend. It automatically labels the axes. Okay, you could have called plot yourself, matplotlib, and provided each of these things, but pandas just kind of does a lot of these things nicely for us by automatically creating a legend, okay, with the column titles, A, B, C, and D, and then just kind of plots these for us. I don't know if I want to do every single one of these things here, okay? But here, all right, and so here they're plotting A versus B and things like that. Okay, just kind of the different stuff here. Okay, here if we just look at one row, okay, looking at just one row, we can create like a bar chart. Okay, so if I just take one row from df dot, I think we just did iloc 5. Okay, this is just kind of like one row of things, and I could say make a plot, and we're going to say kind equals bar. Whoops, what did I do? Did I do something wrong? Oh, I log. Okay, thank you. Okay, so here are the 4 values that I have, and so plot. There's a few options that you can apply here as far as the kind goes, and you've got bars for bar charts, bar H for horizontal bar plots, histogram, box, density, area, scatter, things like that. Okay, and there's a bunch of examples here. Here I've got we've created a data frame here. Let me before I call the thing to plot it. So df2 has 9 different values, 9 rows, 4 columns, and you can call bar on this, and it will create a side-by-side bar plot. Okay, so I've got 9 of these things, and each one of them has an A, B, C, and D value. So we can see that kind of just popping up right here. Maybe I should, can I just round this? Sure, that's fine, okay. Okay, and then you also, you can turn them into stacked bar plots, okay? And again, it's really nice being able to call all of these things just directly from pandas, okay? So make sure you kind of just read through the examples and just try some of these out, okay? With histograms, you can do the same kind of stuff. All right, so I'm going to go ahead and just show you what. Here we've got A is going to be 1,000 random numbers plus 1, B is 1,000 randomly distributed values, and C is 1,000 randomly distributed values with a mean of -1, okay? And we're going to specify columns A, B, and C, and here we can call plot.hist, and we can specify different options like alpha equal to histogram, And any of these things, you can always just kind of click them for more of the keyword arguments, right? And so here is just a histogram where 1 is random uniform between 1 and 7, and then here's random uniform values from 1 and 7, and when you add them together, you might get this is like the distribution of rolling 1 die, okay, from 1 to 6 show up equally, and then the distribution of rolling 2 dice have this distribution. 2 is least likely, 12 is least likely, and 3, 4, 5, 6 is a little bit more likely. So what's the distribution of rolling 3 dice, right? Or 2 dice? Oops. At what point does this become normal? So we can do df3, and we're going to just take 2 and add a thing. I'm going to just keep doing this. The sum of 4 dice. And then let's just do df plot histogram. Is equals 28. Did I do something wrong? I want the right number of bins here. Okay, here we go. Yeah. So you can see uniform, and then as we get the sum of more and more dice starts to look more and more normal, right? So the sum of a certain number of randomly uniform distributed values, the sum of those values become more uniform. Okay. But anyway, all right, more normal. So all sorts of stuff you can do, and again, if we just took a look at the head, it's just adding some random values together. Okay, so lots of cool stuff on this page for visualizations. There's you can have stacked histograms. I don't know how often we use stacked histograms ever, if ever, but probably. And if you wanted subplots, this can also be done. Okay, as far as the outputs go. Here's some stuff for box plots. Okay, so I strongly recommend that you read through this and try some of these things out on this page. It's a fairly long page, okay, but there's lots of options for scatter plots, and these are all visualizations that you can call directly from pandas. Okay, as far as the things go, I would say the earlier examples are probably the ones with the series, and the bar plots probably going to be the ones you use most frequently. Okay, so check those out. All right, I'm going to go ahead and skip down to the Seaborn stuff. Okay, and so for Seaborn, you call import Seaborn as SNS. So that's kind of the common way to import Seaborn. And Seaborn is useful for visual exploration. So you're doing some exploratory data analysis. Seaborn is really handy for this in that you can just do some quick explorations of like the density, quick explorations of some box plot versus the other. It's not intended for direct modeling. So you can fit like what would it look like if I fit a linear regression line, but it's not intended for you to be able to pull out what is the slope and intercept and r-squared value, okay? It's just kind of like, this is kind of what a linear regression line might look for, okay? So Seaborn's for visual exploration, but you can't use it for extracting model information. Okay, this first thing, set, is to kind of set aesthetic parameters, okay? And here if I just do sns.set, it's going to just say use the defaults, okay? So here I'm going to just start by calling numpy random, and I'm going to ask for 100 random normal values, okay? All right, and then the first thing I'm going to do is I'm going to call SNS Seaborn distribution plot, okay? And so just like anything else, you can always ask for Seaborn displot. All right, so we got sns.displot, Seaborn displot, and it specifies all of your options, and it provides the examples. So what it's going to draw is exactly this. Okay, so here's it gives me a histogram of my 100 random normal values, and then it also plots a kernel density estimate. Okay, so just kind of a smoothed out line to try to give us an estimate of the density. Now there's other options here. So again, read the help file and you can see all of the different arguments you can have. You can specify the bins, histogram true false, KDE true false, rug true or false, fit, histogram keywords, KDE keyword arguments, rug keyword arguments, fit keyword arguments, color, vertical, norm, all of these things, right? And they got all sorts of options, okay? And so let me just show you a few of these things. So rug, do you guys know a rug plot? Okay, so a rug plot, so what I did here was I said KDE equals false. Okay, so it's the exact same data as before, but I'm saying don't draw this kernel density estimate. Make 20 bins, okay? And then what we have here is the rug plot. And the rug plot is basically, it shows in tiny little hairs of where the actual values are. So the 100 random normal values, we can see there was one value right here, and that's why it's there's a bar here that has a height of 1. And there's one little hair right here indicating that there's one value, and that's why we've got here. And if you count how many actual values, so this is just a kind of the rug plot's a way to see the actual values that were selected in a, I don't know, less obtrusive way, okay? It just plots little hairs regarding at exactly the location the value is drawn, right? If you just want the kernel density estimate but without the histogram, you can specify those options. So here I have histogram is false, but rug is true, and so we get the kernel density estimate and the rug plot. And you can also call KDE plot directly, and you can specify things like the bandwidth parameter, okay? So so here that's bandwidth 0.2, bandwidth 0.12 will make it more jagged, whereas if I specify a larger bandwidth, it just makes it more smooth, right? So those are different options. It's got some kind of default for how it selects the bandwidth, but basically Seaborn I think Seaborn, I think, just does a nice job of plotting some pretty things. If the plot you want fits fits the thing that you want, if they have a plot exactly the way you want it. So again, just like everything else, you can go to the Seaborn documentation, you can click the gallery, and it kind of has like all of these different things that you want, and you go like, oh yeah, I want to make something that looks like this, and it will have basically the arguments that you can call to do this. This is pretty much how you can do a lot of stuff, right? You just say like, oh, I want to be able to, this is kind of something that I want to do, and then you look, and then you say, how is this called? So this is kind of your grouped bar plots and things like that, all sorts of stuff. Okay. So different options there. Okay. So here I'm going to generate some multivariate normal data. So I'm going to start off with a mean of 0, 0. And then I have specify a covariance matrix, okay? So the variance of each of these things is 1, and then there's a covariance of 0.5 between the two. And I'm going to say, I'm going to call numpy to generate some multivariate normal data, right? So this is kind of your random multivariate values with this mean covariance, and I want 200 of these things. And that's going to produce a numpy array called data, and I'm going to turn data into a data frame by just calling pandas data frame on that. So this is going to be a 200 by 2 numpy array, and we're going to make it a 200 by 2 pandas data frame by calling data frame on it. Okay, so if you just take a look at the head of the data frame, this is what it looks like. I could probably have gotten rid of the print. Okay, so this is a first 5 rows of our data frame. Okay, and remember all of that work that we like. Okay, so remember making this thing? You had to call grid spec, and I didn't even bother with this. I just copied someone else's code because it was such a pain. So you could do this, okay, and it's a one-line command here. Okay, it's just joint plot. So you say joint plot, and boom, you get pretty much what you wanted. Okay, you get the scatter plot right here, and then the histograms for each variable individually from Seaborn. Okay, and so we can see this is kind of what the joint multivariate normal looks like. Okay, and individually, if we look at each variable alone, it looks like a normal distribution, which is exactly what we want. Okay, there's all sorts of different options you can also specify for the joint plot. So instead of having the dots, I could say I wanted a kernel density estimate, and it does this. Okay, and again, anything you can just type in Seaborn joint plot. Get the documentation, read through that, see the different examples that that you might want to obtain. Okay. This is the sepal width and petal length data set. Okay, and we can see there's at least 2 distinct clusters as far as petal length goes, right? As far as sepal width, harder to distinguish. So, and we know that there's 3 species as far as the iris data goes. So all sorts of stuff. I think, during your projects, I think, my opinion, you don't have to. No one's required to use any of these things. But I think for some of the things, Seaborn will make some plots really easy and nice for you. Yeah?
You had stated that you can't use Seaborn to extract model information.
Correct.
I was just wondering if you can elaborate.
So later on I'll show you stuff where like you can use Seaborn to just like something like this, where you get like this, it looks like a fitted line, Okay. Now, generally in R, if you draw a fitted line, you first have to like fit the linear model, and you get like the slope and the coefficient, and then you ask R to plot that slope and coefficient on here. Okay. Seaborn will draw this line along with like confidence intervals around it, but if you say, okay, well, what is the slope and intercept of this line? Seaborn refuses to give it to you, okay? Like it has obviously calculated what the slope and intercept is, but you cannot pull it out of Seaborn. Seaborn, like philosophically, says, I don't want to tell you the regression model. Like if you want to figure out the regression model, like figure it out yourself. I'm here for visual exploration, okay? And you can say like, okay, this is what a linear model looks like, and you can look at it and decide if it's appropriate or not to pursue fitting a linear model. And Seaborn will say this is what it looks like if you try to fit a linear model, but do not use this linear model. I'm not gonna tell you the slope, the coefficient. I'm not gonna tell you anything about any of this stuff. Okay, and so it's a little strange because we're always used to getting all of this information in R prior to drawing our plots, and Seaborn is really just like, here's a bunch of like quick and easy things to draw plots, and then if you want to explore something. Okay, so here we're going to load up the nice little iris data set. And you can run something called a pair plot, okay? So pair plot will plot every single variable against each other, okay? There's something similar in R called pairs, okay? But the nice thing is that it also plots histograms for the individual variables by themselves, right? So when it's sepal length and sepal length alone, it plots an individualized histogram, okay? And then, petal length and petal length alone, we can see, oh yeah, there's definitely two clusters that show up in this data set all by itself. And then in the pair plots, we can see definitely two different clusters here, okay? We know that there's 3 species out there, okay? So, so that's pair plot. And so what you can further do is you can say, well, call pair plot and color the dots hue equals species. Okay, takes a moment to figure this out, and but it does it for us. Oh, okay, my computer is like choking. Okay, here we go. All right, and so which is impressive. This would have taken forever to try to like make these plots individually. Okay, but Seaborn does it for us. One nice line. You've got. I mean, granted, this data set is super nice to work with, right? It's 4 numeric variables, no missing values, 3 categories. It's such a like clean data set to work with, so it's like perfectly suited for this kind of thing. But it's also really nice to see this, right? So we can see the individualized kernel density estimates for each of the species, and it also already puts the labels for us, okay? Setosa is blue, versicolor, and virginica are orange and green. And so we can see the petal length distribution here, and then we can see how they get plotted like this, okay? And so, if you had to pick 2, I would have probably just picked petal length and petal width, and I could probably classify just based on those 2 things, right? Just slice right there and slice right there. Okay, be pretty accurate. Yeah.
Why is it that you get a density plot? Like I got like the bar plots.
You got bar plots?
Yeah.
I don't know. That's weird. I don't know. Let's see. Seaborn pair plot. I'm sure there's an argument where you can say I want something. I just followed these examples. What's your Seaborn version? You might have a different version of Seaborn. I don't know. let's see. So you can type in, so any package you have, so Seaborn dot and then underscore underscore version underscore underscore, and maybe you have an older one, I don't know. Or you have 090? Something's not right. So I just have SNS dot underscore underscore version underscore underscore. So I think this is the latest version. And then, and if you need to update any of your things, you should try to keep your software updated, right? So you can always just do conda update Seaborn or something like that. Uh-oh, I broke something. Okay. It wants to do all of this stuff. Okay, I'm gonna say no. I don't want to do this right now. Okay, but okay. So I get to run some updates here. All right, so that's the Seaborn pairs plot. Okay, I think Seaborn's great in terms of just like quick graphics. All right, I know some of you guys for your meeting with the data, you like did some initial exploration of the data, but like most of you did it in R, which is like the opposite of what we should be doing. Not the opposite, but just like what you want to do is you want to purposely force yourself to use Python, which you are not comfortable with, so that you become comfortable with it, right? Like if you want to get better at writing with your weak hand, you've got to practice using writing with your weak hand. Like I don't know why anybody would, but you know, you got to practice the thing that's hard if you want to get better at it. So, so Seaborn's really great in terms of making some of these things very easy. Okay, here is the tipping data set. Okay, and so the tipping data set, there's several entries here, 244 entries, and I don't know when this data was collected. Like the total bill for 2 people was $17, and they tipped $1.01. Like this must have been like 1975. I don't know when this was, right? Like this is like one burrito at Chipotle. So, all right, okay, and this was, and so we have the is this the? I don't remember. Let's look up the tips data set. Nope, that's not what we want. Is there a data dictionary here? Data repository. Okay. All right, I gotta look up. I think sex is the sex of the server, or maybe the primary patron, the person who paid. Maybe the sex of the person who paid, whether that person was smoking or not, right? Like there used to be, maybe in other states they still have smoking and non-smoking sections of the restaurant, but not in California, right? California has done away with that. Okay, so anyway, there's several of these things, okay? And unfortunately, Seaborn gives us terrible names for these things, okay? We've got the strip plot, the swarm plot. I don't know I've never heard of strip plot, okay? But basically, it's a dot plot, okay? But I guess it plots it in a strip. I don't know. All right. Okay, so here I just said X is going to be the day. All right, we have information on Thursday, Friday, Saturday, Sunday as far as the different days go. Okay, so automatically recognizes that day is a categorical variable. Okay, and plots one according to the categories. And then as far as the total bill goes, which is numeric, it plots it like that. Okay, we say data is tips. We have jitter equals false. If I turn jitter equals true, then it just kind of adds some horizontal jitter so that so that you can kind of get a sense of like the density here, right? Because right here all the dots are just plotted straight on top of each other, and that's undesirable. There's something called a swarm plot. Okay, a swarm plot is kind of like it's a dot plot histogram type thing, but I guess it's symmetric. Okay, so they do it like this. Okay, so rather than just spreading them out that way, you get a sense of a little bit of shape, but they make it symmetric, and you get this. Okay, now what you could do. So this is so by default it just kind of gives each category a different color, but you can specify the color or the hue based on one of the variables here. So I'm going to specify hue equals sex, okay, based on another categorical variable. So now I'm plotting 3 different variables in this thing. We've got day, total bill, and sex. Okay, and so this part looks exactly like this, at least the data points go, but if you are able to see the colors, you can see, the orange dots are female and the blue dots are male, okay? And so we could see on Sunday, we had lots of male, and then on Thursday, there were quite a few more female, okay? For whatever reason, all right? It's hard to fully distinguish, okay? All right, here I'm going to put X as the sex variable, so we're going to have one swarm plot for males and one swarm plot for females, and then I'm going to do hue as day, and so we're going to have 4 colors, one for Thursday, one for Friday, one for Saturday, and one for Sunday. It's going to be hard on the eyes, okay, but I'm going to do it just so you can see that you can swap these things around, and again, it's hard on the eyes. So this is what the distribution for males look like, the distribution for females look like, and we can see, in this data set, more males than females. It seems like the average for females is a little bit lower for the total bill than the average for the males, okay? But as far as the dot color goes, Thursday, Friday, Saturday, Sunday, I'm having a hard time seeing anything with my eyes because it's like too much color and it's a mess. It's right there. It's not as interpretable or easily seen. Okay. I like box plots. Okay. I always have. All right. So box plots, easy, right? Day, total bill, boom. All right. It's exact same information as this, but I think this is a lot more easy to interpret, the box plot versus the swarm plot. Because the box plot you get right away the median and the minimum, the max Q1, Q3, right? Did I do the exact same? Okay. Here, I just swapped Y and X, okay? And that just makes it horizontal. So no biggie. All right. You can also specify hue equals sex and you get these side-by-side box plots, okay? So now I get the Thursday, male, female, Friday, male, female, Saturday, male, female, and Sunday, male, female, okay? What you lose when you do a box plot versus doing the swarm plot, okay? What you lose is the number of observations, okay? So over here, you can't tell, were there more males or more females? You can't tell with the box plot. You just get the summary values. Okay, the last thing is the violin plot, okay? These are like the worst, okay? It's this, okay? It's this. It's the same information as this, except I guess you get I don't know, kernel density estimate type shapes, okay? You can look up a comic, XKCD, on violin plots. It's kind of humorous, but not a huge fan. Okay, so that's what we have for stuff. But I think box plots, side-by-side box plots, I think are great. Other things, not as much. Okay. Facet grids. Facet grids are so awesome, okay? I've got a few minutes. So a facet grid, what a facet grid will do is it's going to take your data set and split it into what they call different facets based on some variable. So here I'm going to say make a facet grid based on sex, okay? Take the tips data, use the column sex to create a facet grid. Okay, that just creates the facet grid. It hasn't done anything yet. Okay, then, so we define the facet grid as G. That's going to be the grid. And then you call map. A map function will say like, then run this thing, okay? And so what I'm going to then do is I'm going to plot a distribution plot. So you remember the distribution plot? That's going to be the histogram with the KDE on top of it, okay? And we're going to plot it, the distribution plot for the variable total bill. And what this will do is it will create a distribution plot where it has subset the data to males and a distribution plot where it has subset the data to females, okay? So, and it does this automatically for you, okay? You could do this manually. You could subset the data to only males and then create a distribution plot. Create a subset of the data for only females, create a distribution plot, and then figure out the grid spec so you can put them side by side, okay? But Facet Grid will do this for you automatically. So actually, I'm sorry, the call, this is set up the grid based on columns. So make basically 2 columns here, and we can do that, okay? Here I'm gonna do Facet Grid row equals day. So I'm giving it a categorical variable day, and we're gonna say build rows out of this, okay? And so it's going to give me, we're gonna map plot histogram. So it's gonna do the histogram for total bill when day is Thursday, day is Friday, day is Saturday, and day is Sunday, okay? So that's Facet Grids. Facet Grids, I think, are super awesome. And you can further do this, okay? You can even create 2-dimensional things. So we're gonna have row is time and column is sex. So time is like lunch or dinner, sex is gonna be male or female, and then we're gonna plot a histogram of total bill based on this. Okay, so I've got, this is total bills for males at lunchtime, total bills of males at dinner time, total bills of females at lunchtime, total bills of females at dinner time, okay? So if you have categorical variables, you can build facet grids, some great stuff, okay? This is the worst. I mean, sometimes you just want a simple bar chart. They call them count plots. I don't know who ever calls these things count plots. So Seaborn is so great, but their naming is terrible, right? So I always have to go, what was that thing called? I go Seaborn, and I want to make a bar chart, and then you go, oh yeah, okay, there's bar plot and count plot, okay? And you go, oh yeah, that's what I wanted to do, because I can't remember this. Okay, so count plot, okay, that's about as simple as it comes, right? And you can also specify here, so I'm going to do sex based on time, lunchtime, and dinner time, and it creates your bar chart, bar plots accordingly, okay? A count plot, for whatever reason they call it that. I guess it's because it's counting up how many times this has happened, but okay. And again, you can also just say, well, what would my data look like if I had fit a linear model, okay? So you just call LM plot, all right? And this says like, okay, this is what a linear trend line would look like if I fit it there. And you can go, okay, that seems reasonable. But again, you're not going to be able to extract out the slope and intercept. It just says, okay, here's the scatter plot, here's the line that runs through it. This is kind of the confidence interval band that we get there. Okay. Low S, you guys know low S regression, local regression, right? Okay, so you can get that and you get something a little bit more curved. Okay, so as far as tips go, what's this showing? It's showing that, at least in this data set, tips are linearly related, so whatever, 15-20% up here, and then as the bills get bigger, people are less likely to tip as much, right? So once the bill goes over $30, now they're on, like, maybe back here they're tipping 20%, and over $30 they're only tipping 15% or something like that. Okay, that's what, at least what this data shows, on average. Okay, here's a generous tipper out here, but you know, we also have to explain these low tips down here. Okay, you can even get a residual plot, okay, just to kind of check model validity. But again, so this, what's this telling us? This is, we've got some issues, right? Non-constant variance, okay, of the residuals, so maybe linear regression is not the best, okay? And you can also specify the color, and I can say, well, let's look at whether they smoked or not. And what do we see? Oh man, the smokers have a much lower slope for tipping. Like they're, at least in our data set, their rate of tipping is much lower, or stuff like that. Okay. You can also do this with a here's the facet grid. Okay, and I'm doing a plot, scatter plot for the smokers and non-smokers and things like that. Okay, but that's Seaborn. Some really neat stuff, made really easy for quick exploration. Okay, so that's what we've got there. All right, I've met most of you. I've got, I think, 2 groups left, but I've met most of you guys, and if you guys have any questions, some of you, I was a little bit harsh on your group thing, so if you feel like you've got questions about what you want to do with your data, just feel free to schedule an appointment or come by during office hours during next week there. All right, we'll see you guys then. Be sure you practice those data camp projects.